Alright, so in this video we're going to learn how to take the derivative of natural log function. So the derivative of the natural log of u with respect to u, okay, and u is some function, okay, so it's really easy. All we're doing is, you see this, what we're taking the natural log of, that goes into the denominator, and then in the numerator is the derivative of what we're taking the natural log of. Okay, so whatever you're taking the natural log of, that goes into the denominator, and then the derivative of that goes into the numerator. Alright, so let's take a look at it, some examples here. So here I have f of x equals natural log of x squared. So to find the derivative, you can see here, this is what I'm taking the natural log of. That's like my u. Okay, so the derivative is equal to, so what we're taking the natural log of goes into the denominator, and then the derivative of this goes into the numerator. So the derivative of x squared is 2x. And then you can see the x squared and the x cancel. I'm left with 1 and an x. And so my solution would be 2 over x. Alright. Alright, let's look at another one. Okay, so same thing. Here's what I'm taking the natural log of, the 2x squared plus 1. Okay, that's my u. So the derivative of f of x is, okay, so what I'm taking the natural log of, that goes into the denominator, and then for the numerator is the derivative of this. So the derivative of 2x squared, bring the 2 down, so that's 4, and subtract 1, so that's 4x, and then the derivative of 1 is 0, and so this is my answer. I'm just going to rewrite it, make it look a little neater. 4x over 2x squared plus 1. And there's my answer. Alright, how about another one? Alright, so here we have f of x equals the natural log of x, all of that raised to the 4th. So here I'm going to have to use the chain rule, because I have something in parentheses raised to a power. So I have, erase that. So f prime of x is equal to, so I'm going to bring the 4 down, okay, and then I have the natural log of x, and I subtract 1 from the exponent, so that's a 3, and then remember the chain rule, you bring the exponent down, subtract 1, and then times the derivative of what's in the parentheses. And so the derivative of that is, okay, what I'm taking the natural log of, x, and then the derivative of that is 1. And so this is going to equal 4 natural log x cubed, all that over x. And there's my answer. Okay. Alright, so let's take a look at one more. Alright, so this one looks pretty bad. Now, if we do the property that we had earlier, okay, if we do this, whatever we're taking the natural log of, that goes into the denominator, and then the derivative of what we're taking the natural log of goes into the numerator. Let's look at this. And this is not how we're going to work it, I'm just going to show you. Okay, so in the denominator we would have x times x squared plus 1 squared over the square root of 2x cubed minus 1. Okay, that's what we're taking the natural log of. And then in the numerator would be the derivative of this. Okay, so you can see here we've got the quotient rule, the product rule, the chain rule. Okay, we've got all of that. And that's going to be pretty messy. And then we would have to simplify it and all that stuff. So let's see, I wonder if there's a better way to do something like this. Well, let's look and see what we've got. Do you remember your logarithmic properties? Remember when you would write a logarithm as a single log, or if you had a single logarithm and then you would expand it, you would write it as a sum and difference of logarithms? Well, that's what we're going to do here. So I'm going to rewrite f of x is equal to the natural log of x plus the natural log. Go ahead and write them all like that. Okay. That's going to be the natural log of x plus the natural log of x squared plus 1 squared minus the natural log of square root. And instead of writing square root, I'm going to write this as 2x cubed minus 1 to the 1/2 power. Okay, so remember, if it's multiplication, that splits up into addition, and if it's division, that splits up into subtraction. Okay, remember, if you have the log of x times y with base b, that's equal to the log of x with base b plus the log of y with base b. Okay, that's the property. That's this when I went to plus, and then the log of x over y with base b is equal to the log of x with base b minus the log of y with base b. See, if it's division, it splits up into subtraction. So these are the properties I used. And then also remember, we also have a property that says if we have the log of, I don't know, let's say x to the n with base b, then that's equal to n times the log of x with base b. We can take this exponent and throw it down in front and multiply it. And that's what we're going to do with this 2 and this 1/2 power. So we're going to actually use all three of these properties. So I have to rewrite this again. Alright, so let me get rid of this. Alright, and so now I have f of x. I'll write that a little bit better. I've got f of x equals, and so this one I'm going to leave alone, so that's going to be natural log x plus, and I'm going to bring the 2 down in front, 2 times natural log x squared plus 1 minus, and then I'm going to bring the 1/2 down in front, 1/2 times natural log 2x cubed minus 1. So now I have this rewritten, and now look what I have. I've just got the natural log of x plus 2 times natural log x squared plus 1 minus 1/2 natural log 2x cubed minus 1. So now what I can do is use this property right here. Okay, on each one of those terms. All right. So now I'm going to go ahead and take the derivative. So f prime x. Okay, so the derivative of natural log x, we know that's just 1 over x. See, the x goes in the denominator, and then the derivative of x is 1 plus 2, this 2 right here. And now let's take the derivative of this natural log. So what I'm taking the natural log of, that goes into the denominator, and then the derivative of this goes into the numerator. So the derivative of x squared is 2x, and the derivative of 1 is just 0. And then that's minus 1/2. Okay, that's this 1/2 here. And then I have what I'm taking the natural log of here. I'm taking the derivative of this. So the 2x cubed minus 1, that goes into the denominator, and then the derivative of what I'm taking the natural log of goes into the numerator. So the 3 comes down, that's 6, subtract 1, x squared, and then the derivative of 1 is just 0. And so let's clean this up a little bit. Let's see what's going to happen. Nothing I can do here. Here I can multiply the 2 times the 2. That'll give me 4x. And here the 2 and the 6 cancel. I'm left with 3 and a 1. So I get f prime x is equal to 1 over x plus 4x over x squared plus 1. I'm going to write that 1 again, maybe a little bit neater. Minus, and then that's going to be 3x squared over 2x cubed minus 1. And this would be our final answer. And if you want to really have fun, you can combine all those, get the common denominator, but I think it'd be fine just to leave it like this. So I hope this video helped, and hope you'll check out my other videos. Thanks.